Okay, now we're going to go on and we're going to do something a little backwards. I'm going to give you the graph and you're going to come up with the equation. So first thing I want you to look at is the parabola. We see that it's opening to the right. If it's opening to the right, we know that it could cross the y-axis twice, which is going to make this be a y-squared parabola. We notice right away that the vertex is at the origin. The vertex is at 0, 0. P is the distance the focus is from the directrix. So then we just have to count. We've got 1, 2, 3. P is 3. And again, this is opening to the right, so P has to be positive. You can double check. The directrix is this kind of gray line here. 1, 2, 3. It's also 3 away from the vertex. So, excuse me, when we write the equation said we have y minus our y value of our vertex, which is 0, squared, because it could cross the y-axis twice, equals 4 times p, and yes, you could simplify that to 12 right away, x minus the x value of the vertex, which is also 0. Make sure you don't square both of them. Then simplify this. Y squared is equal to 12x, and we're done. There's the equation for this sketch. Let's try another one. Notice that this one is opening down. So when it opens down, that means it could cross the x-axis twice. So I'm going to have an x squared in this one. The vertex is at 0, 0, so I'm going to fill that in first. P is the distance from the vertex to the focus. Now, look at that carefully. Look on your paper if you need to, but it goes down 1.5. So I don't really want to write 1.5. I mean, it's really 1.5, 1.5. The better way to write this would be to write it as an improper fraction, so it's 3/2. Since it's going down, that P is going to have to be negative, because that's telling us the direction that this is opening. You can also think you went down 1.5. Check the directrix. It's also up 1.5, so we should be good with our P. When we write this equation, remember we're doing x squared this time. So I'm going to do x minus the x value of my vertex, which is 0, squared, equals 4 times P, remember P is -3/2, y minus the y value of my vertex, another 0. And then just simplify this so it looks a little bit better. We have x squared equals 4 times 3 is 12, divided by 2 is 6, so -6y. And there's the equation for this sketch of this parabola. Okay, if you flip over your notes, you'll see example 3 looks just like what we've already done. I'm not going to skip it though, because notice that we aren't at the origin anymore. So this is where it might get a little bit trickier. We're going to go through the same process though. All right, so take a look at this formula equation. We have an x squared. So since it's x squared, it means that it could cross my x-axis twice, which means it's going to either have to open down or it's going to have to open up. So look at your P, or where P should be. It's right there. So to find P, I would do 4P is equal to -8. P is going to equal -2. So since it's negative, it means that the parabola is going to open down. And again, that was because P was negative. The vertex, now be careful because this is always HK. H is always with the X, K is always with the Y. So H is the opposite of what it looks like right there. So my H value of the vertex is -4, because negative makes that a positive. And remember, the formula was X minus H. My K value is 2. So I'm going to go ahead and graph that vertex. Go back 4, go up 2. Now, the focus is inside the parabola. Since we know this parabola is opening down, and I know that the focus has to be inside the parabola, I'm just going to go down 2 spaces. So that ordered pair is going to be inside the parabola. So that ordered pair happens to be at -4, 0. The directrix is going to be the same distance away from the vertex, but in the opposite direction. So I'm going to go up 2 and make that dotted line. The directrix here is the line y is equal to 4. And then again, the axis of symmetry is what cuts the graph in half, goes right through the vertex and the focus, and so that's going to be the line x equals -4. Notice the directrix and the axis of symmetry are always, one's always x and one's always y. They'll always be perpendicular to each other. That's just a coincidence, they're both 4. The only thing left to do now is to sketch this parabola. Make sure when you're doing your parabola, you're graphing it, you go back to the vertex. Don't graph it from the focus. You need to have a dot inside or a point inside to be the focus. All right, let's try it the opposite way now. Okay, so first thing I want you to look at is to see that this parabola is opening to the right. So it opens to the right, so that means that P is positive. All right, I'm going to look for the vertex. I just think that's always kind of the easiest thing to find. It goes, here's 0, 0 here. 1, 2, 3, so it goes over 3, and it goes up 2. So again, that's my H and my K value. Since it's opening to the right, that means that it could cross, if we shift this back, it's going to cross the y-axis twice, so I'm going to have a y² equation. To find P, again, you have to count how far it is from the vertex to the focus. That's only one space away. Since it's opening to the right, P is positive 1. When we're going to write this equation, I need the y² to go first. So I'm going to just copy the equation here really quick. We have y minus k squared is equal to 4p x minus h. Be careful, here's where a lot of people mess up. The h is always with the x. The k is always with the y. So it's kind of backwards from what maybe you would think. So I've got y minus 2 squared equals 4 times 1 x minus 3. So just be careful that you don't get those mixed up. My final equation is y minus 2 squared equals 4 x minus 3. All right, before going on, I want to just show you guys something here really quick, because I didn't really explain exactly what the focus and the directrix were. So here's this blue parabola. Here's the vertex. The distance here is what we would call P. It's a distance. If you pick any point on the parabola and you draw a line from the focus and a perpendicular line to the directrix, those distances are always going to be the same. It's not P anymore, but P is the shortest distance between the two. But then here's another point on the parabola, and notice that this distance would be the same as this distance. So I just kind of want to, if you do a whole bunch of these, it's going to actually help you graph the parabola. All right, a couple more examples and we're done.